Actually, most of the things happened on coincidence. You develop a plasma source, you do not really know how it works or what it produces, and then you try to find out how to improve the performance of the plasma, and then you just really do tests in the lab. Then you can start and produce the plasma here.
Oh wow, I can see it!
Yeah, yes.
Can I smell it?
Yeah, you can smell it.
Today we are in Garching in Munich visiting Terraplasma. Terraplasma is basically coming from the Max Planck Institute of Extraterrestrial Physics and was founded by Gregor Morfill, the former director of the institute, and Zimmermann. And I'm really super excited to learn about cold plasma. There's a lot of potential behind it for life science. So let's go.
Come in. So this is Terraplasma. Yeah, so here we actually do our daily work. Most of our employees, of course, work in the labs or at their desks. And I think the most interesting part is the lab.
Oh.
What we actually do here is we develop our plasma devices and also our power supplies using high voltage. So Alex here, he is actually sticking together some pipes for our new water setup, which is located in the cellar. Yeah, so this is an ESA project actually, where we we want to treat water with cold plasma to really disinfect the water and produce drinking water.
And you can achieve something that's really amazing. You can get away all these complicated chemicals, right?
Yes, we also did tests with that. So PFAS we tested. Yeah, so actually the most difficult chemicals to treat or to get rid of, which really, actually it's a real threat, or it's getting a threat. Yeah, we have good first results on that.
But did I get it right that this was actually something you found more or less by coincidence, that you can also work on this in cleaning water?
Yes, so actually most of the things happened on coincidence. You develop a plasma source, you do not really know how it works or what it produces, and then you try to find out how to improve the performance of the plasma, and then you just really do tests in the lab on bacteria, on viruses, on fungi, and so on. Yeah, and then at a certain point you somehow know how to control the plasma and how to develop a good plasma device, and then you can optimize this, of course. Yeah.
And I can imagine it was quite hard to actually build all this up, because you have the infrastructure at the institute, and when you build up your company, obviously you have to buy all this super expensive equipment.
Yes, we were quite lucky because we were able to buy some stuff from Max Planck at that time point. Yeah. So they closed down the lab, which we had there. And we're lucky us, yeah. So we were able to buy a few things out. Yeah. But of course, yeah, we invested a lot of money into these labs. Yeah. We were talking about the electrons and the odors. So this was our first prototype. I really like it.
The first from this?
The first was this. And then based on this, we were able to make it at least small.
Yeah.
But okay, it looks really ugly.
Well, it does for a prototype.
Yeah, wonderful switch here, and then you can start and produce the plasma here.
Oh wow, I can see it.
But maybe you can see it like this.
Can I smell it?
Yeah, you can smell it.
Yeah.
And you can also see it.
Yeah, you can. Yeah. Amazing.
Yeah, so what you can see here are these micro discharges.
Yeah.
Yeah.
And that's odor killing.
Yeah, if you use it like this.
Okay.
So you really have to, the electrons, they do not travel far distances in air.
Yeah.
They just collide with air molecules. So that's why you really have to bring the electrons, which are produced in these micro discharges, to the odors in your textiles, for example. And with this, we actually went to Bosch. Said, look, we can do a small, fancy device. Do you want to turn this into a consumer product? And then we had different stages. And this is then the actual device which came out. It looks
a
little bit, looks a little bit nicer, And so in principle, if you activate the plasma source, you can see here the blue light, and you use it like this.
So how long did it take you to go from this stage to that stage?
It depends. So we had a lot of pre-development, of course, at Max Planck. And the basic technology was actually developed at Max Planck. But then, of course, we didn't have plasma sources where the plasma source was, the structured electrode was like thin as it is now. So it looked like that over there. And that you can't rub over a surface because it's not smooth enough. So it maybe took a pre-development of 4 to 5 years, and then another development to get here. And another development with Bosch together of 2.5 years, something like that.
Product development with Bosch, with all respect, in 2.5 years, it's amazingly fast, isn't it?
Yes, they also told us that. But for us, well, we developed a medical device in 1.5 years. So for us, that was actually really slow. But yeah, with Bosch, for Bosch, I think it was fast. Yeah, let's go over to the other labs.
And maybe one further question, you only can't be as quick because you have everything here. Because you can do everything by yourself. You have all the experts who just, they saw it on the computer, you say something and they just make it happen.
Exactly. They design it, they construct it, and then we manufacture it here. So we do prototypes here. So this is actually our best employee. He works day and night. And he's also allowed to do this by law, by German law. Yeah, so here we do all our prototypes, and this really goes fast. This is the good thing. We have an idea, we want to test it. Yeah, then normally Alex, he constructs a prototype, and our best employee works it out. So on the back side here, we have a climate chamber.
Yeah.
Because if you produce a plasma in air, the air is not always the same. So if you go to Japan in summer, you have 80% humidity and maybe 40 degrees. So what we do is then we characterize the plasma inside of this box and see if it still produces the same plasma. You do some tests in there. You can do bacteria tests in here. You can also characterize the plasma, like you can measure how much ozone it produces and so on. So yeah, everything can be done inside. That's the turtle. Exactly. In principle, you have here the 3 plasma sources, and the water vapor comes out here. And this is a device for actually disinfecting surfaces. Yeah. So if you apply plasma in combination with water vapor, it's much more effective. You can reduce bacteria in high amounts in very short time. So you get presumably 4 log within a few seconds. And this is what we want because we actually want to move this over a surface so that you can disinfect the surface without using any chemistry. So we're thinking of putting this into vacuum cleaner robots for different applications in hospitals and so on.
So actually it sounds like a holy grail. You don't need any chemistry, you just need a bit of electricity and a one-time investment. Is there any downside?
Yeah, there's a big chemistry lobby.
Yeah, most probably, right? Yeah.
So here we're in our risk class 1 biolab. Here we can work with microorganisms, mainly bacteria, of risk class 1. If we want to go to risk class 2, we have to use our partner labs, for example, the University Clinic in Regensburg. We work really closely with them. This is the plasma egg.
Yeah.
And it's actually a disinfection chamber. So you can put all stuff in here and you just close the lid and turn it on. And within 10 minutes, 20 minutes, the stuff which is in there is disinfected. The good thing is you don't need high temperatures. You don't have a UV light or anything like this where you have shattering effects. A plasma is a partially ionized gas and it diffuses through all textiles, it diffuses around corners. So you can reach actually every surface which air can reach.
Yeah. And again, it's not poison for us humans. It's just killing the surface of the bacteria, as I understood, right?
Well, what you in principle do is if a bacteria is sitting on a surface and reactive oxygen or nitrogen species attack the bacteria, you get so-called micropores into the cell wall of the bacteria the reactive species can enter the bacteria and destroy the DNA inside.
And it doesn't affect me because according to frequency, you can direct the plasma, or actually you can direct the effect of the plasma. Right? It doesn't harm yourself.
Well, it doesn't harm eukaryotic cells if you design it in such a way.
Yeah.
So for the plasma care device, our medical device, which is for the treatment of wound, we had to design a plasma which inactivates bacteria, but doesn't harm eukaryotic cells. Eukaryotic cells have a different structure in comparison to bacteria. They have they have a cell core, in addition, and even if you penetrate the outer layer, you still have to penetrate a second layer to get to the DNA. So here are of course differences, but it's only about a safe therapeutic window. So you can also make a plasma which destroys eukaryotic cells if you want.
Okay, if you want to, okay.
Exactly. So the thing, or the Terraplasma's core expertise, is to design plasmas for certain applications and that these plasmas are safe. And this was the same with the plasma care, where we worked really very tightly together with the University Clinic Regensburg to design the plasma that it's not harmful for eukaryotic cells.
So I'm very grateful for the day today because I got another example how successfully science can be transferred into society. As they didn't know in the beginning whether their science can be applied beneficially, they just went out and talked to people. So I invite all the scientists, go out, talk to us, and we give our very best to support you to bring science into the society.